So I wanted to give you a little overview of kind of on the economic issue of climate change. And this was a report done by Nicholas Stern, who was the former chief economist of the World Bank. And this was about 3 years old now, but it's still 4 years old. It's quite relevant still. Is when he looked at the cost of action versus inaction. So if we acted now to try to achieve emissions reductions, which the scientific community was saying we needed to achieve, which would get us to about, at the time, actually, the thought was about 550 parts per million, which would be in the atmosphere. Just to give you an idea of what that means, when the Industrial Revolution occurred, parts of CO2 in the atmosphere was at 280 parts per million. It is now at 380 parts per million, and business as usual case is projected to take us up to about 750 parts per million by around 2050, 2060. And so the concern is that we're going to be tripling the amount of emissions in the atmosphere. So regardless of what you think about the science, there's got to be a consequence of putting this much more carbon into the atmosphere, and what are the resulting effects of that. So the idea was, how do you actually start mitigating that? How do you start reducing that? And so according to Nicholas Stern, it would be about 1% of global GDP spent to reduce emissions that would help, in a sense, mitigate the long-term effects and get us into a trajectory of about 550 parts per million. If we were to be more aggressive, which is what the scientific community is now saying to us, remember they're depressing a lot right now, and they're saying that things are moving faster, so we need to reduce even stronger. To get to about 400 parts per million would be about 1.8% of global GDP. Just to give you a comparable, and what I like about this is because it's about risk management ultimately. And if you think about what the risk management side of it is the global spend on insurance is about 3.3% of global GDP. World's largest industry, the insurance industry. And so by comparison, a risk management approach to dealing with this issue is about another 1.8% if we were to effectively deal with it. And to give you an idea of the magnitude of the solution or what we would need to do, and this is massive. So to be frank, this is when people look at the study done by Robert Socolow and Stephen Pacala in Princeton, they look at this and they say, you know, the average person says, well, some of this seems reasonable, some doesn't. But the idea is you have to take 7 gigatons, 7 billion tons of, of carbon out of the atmosphere year in and year out, which according to their report, which was in 2005, starting in 2005. So we're already further behind the curve. But you would need to take 7 gigatons of carbon out of the atmosphere. So what they did is they divided that up into what they call 7 wedges. And a wedge meaning 1 billion tons of carbon. So what type of technology, what type of deployed resource could actually take 7 gigatons of carbon out of the atmosphere? So just to give you some ideas and to just show the magnitude of what needs to be done. On wind, for instance, it'd be 2 million 1 megawatt wind turbines, which actually, by the way, the average wind turbine, if it was offshore now, would be about 2.5 megawatts. So, but it would cover an area about the size of Wyoming, which actually, to me, actually sounds like, well, that seems feasible if you think globally, covering an area about the size of Wyoming to take 1/7 of the problem out. Actually makes sense, and it actually seems achievable over 50 years. Solar, as a New Yorker, actually, it actually makes a lot of sense because it's about covering the state of New Jersey, the size of the state of New Jersey, which I think is a good choice for New Jersey. Nuclear is actually quite interesting because nuclear would actually be tripling current capacity. And if you think about the whole controversy with Iran, for instance, the countries that are trying to build nuclear power plants, we don't want them to build nuclear power plants for other reasons. But where would you put all these? Whose backyard? There would be absolutely a huge NIMBY problem to put in a tripling of the amount of nuclear power plants. And that's not even counting the replacement of a lot of existing plants, which are about 30 to 40 years old now, and therefore nearing the end of their lifespans. But there's also opportunities on reforestation. You could stop deforestation completely, and you would then have to reforest at a rate about 5 times the amount that we're currently doing that. without doing any further deforestation. So huge undertakings. But what I liked about the wedges, and there is a whole slew of a menu approach, you could say, of technologies. They went through, I think, about 16 different technologies, is that there are some that seem reasonable and some that seem quite daunting, and I can't see how we would ever get there.